Hello students, let us continue with the chapter Structure of Atoms and Nuclei. In the previous video, in part number 5, we have studied hydrogen spectrum. Hydrogen spectrum is a line spectrum, and Rydberg's formula also we have derived. Rydberg's formula. This formula is useful for determination of lambda of spectral line in the hydrogen spectrum. The Bohr atomic model very well explain hydrogen spectrum, but still there are limitations of Bohr atomic model. So what are these limitations? We will see one by one. This model could not explain the line spectrum of atoms other than hydrogen, except हाइड्रोजन. सिर्फ हाइड्रोजन के लिए बोर का मॉडल सही था. और दिस मॉडल कैन बी ऑल्सो valid good for hydrogen like atoms, means singly ionized helium, doubly ionized lithium. For this the model is also valid. But other than hydrogen atom, means hydrogen atom consists of one electron in the first orbit. If there are two electrons in the first orbit, the model could not explain line spectra of such type of atoms. So सिर्फ हाइड्रोजन के लिए ही ये मॉडल सही था. The second limitation is the intensities of emission lines differ from line to line. The atomic model could not explain this also. Means suppose, for example, there are two yellow lines in the spectrum, Y1 and Y2. One is of more intensity and another is of less intensity. So why there is a difference? This cannot be explained on the basis of Bohr's atomic model. The third limitation is the second postulate about stability of atom has no theoretical base. It is only a postulate. It has no proof, no theoretical base for second postulate. What is the second postulate of Bohr's atomic model? Electron revolve in the Bohr orbit. Bohr orbit means stationary orbit, stable orbit, without radiating energy. But there is a condition. Which is the condition? The angular momentum of electron is integral multiple of h upon 2 pi. The electron, when satisfies this type of condition, it does not radiate energy. So this is a stable orbit. But what is the proof? What is theoretical base for this assumption, this postulate? There is no theoretical base. बोर ने सिर्फ कहा था यही होता है, but there is no proof, no practical proof also. So on the theoretical side, this model was not entirely satisfactory. But later on, explanation is given by de Broglie, the another scientist who gave the explanation of this second postulate. He applied his postulate of particle theory, wave particle theory for this electron and proved that angular momentum is nh upon 2 pi. So let us see the proof of this postulate, which is given by de Broglie explanation. So let us see, and this question may be asked for 2 marks in the board exam. De Broglie explanation. Proof of Bohr's second postulate. We know the hypothesis of de Broglie. What is the hypothesis? A wave is associated with the moving particle. This hypothesis is applicable for only microscopic particles, not macroscopic, and the wavelength associated with the wave is given by h upon p, where h is Planck constant and p is momentum. So this can be written as mv, which we have studied in the previous chapter. Now what is the explanation given by de Broglie? So first point is electron orbiting in a circular orbit can be considered as a stationary wave. Means this electron which is revolving in the circular orbit, don't consider this as a particle. It is not a particle. The electron is not a particle, but it is a wave. A standing wave is formed in the orbit due to motion of this electron. Standing wave or stationary wave. So electron when revolves, a stationary wave is associated with this electron. The second explanation is, second point, the wave can survive for which length of orbit is equal to integral multiple of wavelength. This is the de Broglie wavelength. And we will get the same angular momentum of electron which is given by Bohr's second postulate. And what is the meaning of this explanation? The wave can survive, the standing wave can form or survive in the orbit for which the length of orbit means what? It is a circumference. Length of orbit means circumference, and it is equal to integral multiple of wavelength. Wavelength is this wavelength, that is de Broglie wavelength. So how this you can show by diagram. So in the diagram, in the textbook diagram, the standing wave is shown in the fourth orbit because it is very simple to draw. So see here, the orbit in which electron is moving. So this is a fourth orbit. This is a fourth orbit. And radius you can write as r4, but here it is shown as simply r. So draw the circle and divide this circle in 4 parts and then draw the stationary waves. So this is very simple. So 4 stationary waves are formed. So you can draw easily the stationary wave in this fourth orbit. So this diagram is given in the textbook. Now apply the hypothesis of de Broglie hypothesis to this electron. Then you will get Bohr's second postulate in mathematical form. So let us see how this mathematical expression can be obtained. Mathematical proof. Length of orbit of electron is n lambda, where lambda is de Broglie wavelength. De Broglie wavelength. And this can be written as length of orbit as circumference. So for nth orbit you can write twice pi Rn equal to n lambda n. Next we will solve by de Broglie hypothesis. Lambda is equal to h by p, h upon mv, just we have seen this hypothesis. So twice pi Rn, nh upon mvn. So only this is substituted, n lambda instead of lambda, h upon mv, and for nth orbit it is written as vn. So next transfer the terms mvn rn. So take this 2 pi to the right hand side at the denominator place and mvn to the left hand side in the numerator place. So this is the equation. And mvn rn, what is mvr? It is the angular momentum of electron in the nth orbit. So this is nh upon 2 pi. So this can be written with the symbol ln nh upon 2 pi. So this is nothing but Bohr's second postulate. So this is a proof of Bohr's second postulate. So de Broglie apply his postulate to the electron which is revolving in the circular orbit. That is, don't consider electron as a particle, but consider electron as a wave. And we get this proof. Now let us solve some MCQs. Choose the correct option. The first MCQ is, in which of the following system will the radius of first orbit, the orbit is selected here, first orbit of the electron be smallest? And the atoms are given. A. Hydrogen, B. Singly ionized helium, deuterium, tritium. So these are similar to hydrogen. Similar to hydrogen. Atomic number is same, but here singly ionized helium. Atomic number is different. So here we know R is inversely proportional to, the orbit is fixed, so inversely proportional to atomic number. When the orbit is fixed, it is directly proportional to n square, but inversely proportional to atomic number. So the answer is B. Answer is B. Second MCQ. The radius of fourth orbit of the electron will be smaller than its eighth orbit by a factor of 2, 4, 8, 16. The electron in the same atom, so Z is same, so don't consider proportionality with Z, only consider proportionality with number, principal quantum number. So R is directly proportional to n square. So you can write R1 upon R2 is equal to n1 square upon n2 square. You have to find out R2. So R2 is equal to R1 n2 square upon n1 square. Or you can radius of fourth orbit. So you can take this R1 is equal to R2 n1 square upon n2 square. Only I have to find out the factor. So n1 square, so R1 by R2, you can R2 n1 square is 4 square 16 and 8 square is 64. So this is R2 by 4. So the factor is 4. The next question. Next is, in the spectrum of hydrogen atom, which transition will yield longest wavelength? So generally we remember that when the line which we draw in the spectrum, when it is short, the wavelength is long, and when it is long, the wavelength is short, but it is in a specific series. This we can remember for specific series. But here the series is not given, the general is asked. So we have to remember how the energy levels are specified. How the energy levels are specified. So here if we draw energy level just for revision, so space between the energy levels goes on decreasing continuously as the number of orbit goes on increasing. Principal quantum number when increases, energy gap or space between energy levels goes on decreasing. So here if we draw n is equal to 1, then second here, then third, then fourth, then fifth, then sixth, then seventh, and then eighth. So here the space or gap between energy levels goes on decreasing. So if we take the transition from 2 to 1, which is given in the A, so 2 to 1 is like this, then 5 to 4, so this is 3, this is 4, this is 5, 6, 7, 8. 5 to 4 is like this, 7 to 6 is like this, and 8 to 7 is like this. So this is the shortest. So wavelength is longest. So the answer is D. The next, similar to NEET MCQs, this is the one MCQ. An alpha particle of energy 5 mega electron volt is scattered through 180 degree. So by a fixed uranium nucleus, the distance of closest approach is of the order of, these are the given, minus 11 10 raised to minus 11 10 raised to minus 12, this is in centimeter, all are in centimeter, minus 15 and 10 raised to minus 16 centimeter. So here we should remember the formula for distance of closest approach. This is the formula, 2Ze square upon 4 pi epsilon 0 Ke square. So if you put the values and solve this randomly or approximation with approximation, then you can get the correct answer. So put the values, 9 into 10 raised to 9, 1 upon 4 pi epsilon 0. This is 9 into 10 raised to 9. So this is known. The next is 2 Ze, uranium for it is 92. Then E square, E that is charge on electron bracket square upon kinetic energy, which is given in mega electron volt, which is converted into joule. So 5 mega electron volt, when it is converted into joule, this is the 5 into 10 raised to 6 into 1.6 10 raised to minus 19. This is in joule. So solve this with approximation. This charge E get cancelled. Then solve like this. 10 to the power minus 16. So this 6, when goes to numerator side, it becomes minus 6. Then minus 19 minus 6 becomes minus 25, and this is a plus 9, so 10 raised to minus 16. Then next, 9 into 2, 92 into 1.6 becomes 147.2 10 raised to minus 16 upon 5. Then solve this. The product of 2 into this, it is 294.4. Next is into 9 upon 5. Approximately you can find out this answer. 529.9 10 raised to minus 16. This is in meter. So you want to find out order of magnitude. So the decimal point should be here. 0.5299. This you can write as 0.53 also. 10 raised to minus 13 meter. But here the options are in centimeter. So what you have to do? You have to convert it into centimeter. So in centimeter you have to multiply it by 10 raised to 2. So this is 10 raised to minus 11. 10 raised to minus 11. So multiply by 2. Multiply by 10 raised to 2. You will get 10 raised to minus 11. So answer A is correct. The second MCQ similar to first type. This you can solve. Here the energy is different. The alpha particle of energy 10 mega electron volt is scattered through 180 degree. Then the order of magnitude of closest approach is, distance of closest approach is. These are the given. You can solve by taking 10 mega electron volt. In the similar way, you can find out the correct option. This is different. In alpha particle scattering experiment, the number of particles scattered per minute in a direction perpendicular to the direction of incident particles is 40. Means scattered in the direction perpendicular. The number of alpha particles are 40. The number of particles scattered at an angle 60 degree per minute is. So this is asked. When scattered angle is 90 degree, the alpha particles are 40 per minute. And when these are scattered through 60 degree, how many alpha particles are there? So these are the options: 90, 120, 160, 180. So we know the formula for number of alpha particles, or this can be written n is inversely proportional to 1 upon sine raised to 4 theta by 2. N is inversely proportional to sine raised to 4 theta by 2. So for two number of particles scattered, n1 by n2 is equal to sine raised to 4, because this sine is at the denominator place. So you have to take theta 2 on the numerator side and theta 1 at the denominator side. So n2 is equal to n1, the remaining is same, then put the values. 40 is n1, sine raised to 4, perpendiculars mean angle is 90 degree, then another for it is 60 degree. So divide by 2, you will get sine 45, sine 30, but raised to 4. So this is sine 45 is 1 upon root 2. You have to take it the fourth power of 1 upon root 2. And sine 30 is 1 by 2. So take the power fourth. Then this will be 40 into 1 by 4, 1 by 16. So solve this, you will get 160. So this is the correct option. So this type of multiple choice questions will be asked in NEET and JEE and not in CET. So in the next video, we will study nucleus. Study of nucleus in the next video.